Today's notes are on similarity word problems. So it says you can use similar triangles and measurements to find distances that are difficult to measure directly. This is called indirect measurement. One common problem involving indirect measurement uses the fact that light reflects off a mirror at the same angle in which it hits the mirror. Another common problem uses similar triangles that are formed by certain figures and their shadows. So when we look at example 1, it says Nina was curious about the height of the Eiffel Tower. She used a 1.2 meter model of the tower, which is here, and measured its shadow at 2 p.m. The length of the shadow was 0.9 meters. Then she measured the Eiffel Tower's shadow, and it was 240 meters. What is the height of the Eiffel Tower? So now we can solve this. So it's always good to underline the question so that you make sure that you answer that at the end. But using these two triangles here, we can set up our equation. We start with what we want to find. We have x over, and that's proportionate to this side in the small triangle. So we're going to put the 1.2 is going to go under that, equals. Now you have to remember, the numerators have to come from the same figure. So we have to put the 240 up here because we had x. These two have to come from the same triangle. 240 over 0.9. And then we can solve for x. So that we're going to cross multiply, so that's going to give us 0.9 x equals 240 times 1.2. It's 0.9 x equals 288. Divide by 0.9, divide by 0.9, and we're going to get x equals 320. Now we have to go back and make sure that we answer the question, what is the height of the Eiffel Tower? So we're going to write the Eiffel Tower is 320 meters. Don't forget your units, meters tall. And you're going to put that, your final answer, in the box. Example 2. Natasha places a mirror on the ground 24 feet from the base of an oak tree. She walks backward until she can see the top of the tree in the middle of the mirror. At that point, Natasha's eyes are 5.5 feet above the ground, and her feet are 4 feet from the image in the mirror. Find the height of the oak tree. So again, we're going to set up our equations. So we have here, if we start with the 4 feet, what we need to find is the height of the oak tree. So that's here. So we have this distance is 4 feet, and that corresponds with this distance in the big triangle. So we're going to put 24 here equals. Now remember, the numerators have to come from the same triangle. So we're going to put the 5.5 on top, and then that's going to be over x, because this side of this triangle corresponds with this side of this triangle. Just like if you rotate it that way, you can see it. So this is our equation. So then we're going to solve for x. So we're going to cross multiply, and we're going to get 4x equals 24 times 5.5. 4x equals 132. Divide by 4, divide by 4, x equals 33. That's not our final answer, that's what x is. And it said find the height of the oak tree, so we're going to say the oak tree is 33 feet. Don't forget your units, tall. And that's our final answer. Example 3. To estimate the height of the Yinmao Tower in Shanghai, a tourist sights the top of the tower in a mirror that is 87.6 meters from the tower. The mirror is on the ground and faces upward. The tourist is 0.4 meters from the mirror, and the distance from his eyes to the ground is about 1.92 meters. How tall is the tower? So we want to figure out how tall the tower is. So we know that the tower forms a right angle with the ground, and there's a right angle here. So we see that, and then the light's going to reflect off the mirror at the same angle that it shines in on. So we know that these two angles here are also congruent. So we know the triangles are similar by the angle-angle similarity. So we can use that to form our equation. Now it's already been labeled for you, the diagram. So if we start over here, we have 1.92 meters, and that's going to correspond, the height of the person is going to correspond with the height of the tower, which is x, which is what we're trying to find, equals, now the numerators have to come from the same triangle, so your 0.4 is going to go here, and then the 87.6 is going to go on the bottom. Now we need to solve for x, so we're going to cross multiply, so we're going to get 0.4x equals 1.92 times 87.6. So that's going to be 0.4x equals 168.192. Divide by 0.4, divide by 0.4, and you get x equals 420.48. So the question was, how tall is the tower? So we'll say the Yinmao Tower is 420.48. Don't forget your units, it's meters tall. And that's your answer. Example 4. Keenan wants to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet at the same time. What is the height of the Sears Tower? So we know that similar triangles are formed by objects and their shadows. So we can say the triangles are similar. So now we need to set up our equation. So the small triangle's here, and then this would be the big triangle, this being the Sears Tower, and this being its shadow on the bottom. So we can set that up. If we start with 12 is the light pole that he measured the shadow with. So 12 over the height of the tower, which is what we need to find. So that's x equals, again, the numerators have to come from the same triangle. So we have to put the 2 on the top, and then that's going to be over, this whole length is 242. It's labeled for you, 242. So then you need to solve for x. We're going to cross multiply. 2x equals 12 times 242. So that's going to be 2x equals 2,904. Divide that by 2, divide that by 2. X equals 1,452. And so it's, what is the height of the Sears Tower? So our answer is the Sears Tower is 1,452 feet tall. Example 5. 2 extension ladders are leaning at the same angle against a vertical wall. The 3-meter ladder reaches 2.4 meters up the wall. How much further up the wall does the 8-meter ladder reach? So this is the question. We have to make sure that we answer at the end. So it says that they're leaning up at the same angle against the wall. So these angles would be congruent. So again, they would be, the triangles are similar by angle similarity. So we know we have the two triangles. For this one, it might be easier to draw the small and then the big triangle to see, since the small triangle is inside the big triangle. But so you have the 3-meter ladder. So this is 3 meters, reaches 2.4 meters up the wall. And then we want to know how much further up the wall does the 8-meter ladder reach. So using this, we can set up our equation. We have the 2.4 over x equals, remember the numerators have to come from the same triangle, so 3 over 8. We're going to solve for x, cross multiply. 3x equals 8 times 2.4. 3x equals 19.2. So we have x equals 6.4. So it reaches 6.4 meters up the wall. But the question's asking how much further up the wall does the 8-meter ladder reach? So you're not done yet. It reaches 6.4 meters up the wall, but then you have to subtract the 2.4 meters from the shorter ladder, to get the difference. And that equals 4. So your answer is going to be the 8-meter ladder reaches 4 meters higher up the wall. So again, this 6.4 is how high it reaches off the ground, but it's asking how much further up the wall does it go than the 2.4 meters. So you have to do 6.4 minus the 2.4 to get the difference. So your answer is 4 meters. Example 6. Richard needs to know the distance across the pond below. Use similar triangles to help him find the distance. So you have your small triangle is here, and then you have the bigger triangle is here. So we're going to set up our equation. So we'll start with this length here is 20 over, and the length, the distance across the pond is labeled as D, so we'll put D instead of X this time. And then that's going to equal, now remember the numerators come from the same triangle, so we need to take the 280 meters, and we're going to put that over. Now this says 70 meters, but this big triangle is the whole triangle. So you have the small triangle, that's 280 meters here and 20 meters here, and then we have the big triangle with which is D, the distance of the pond we're trying to find, and then this is 70 plus 280, so that would bring you to 350 meters. So you have to add these two to get the full distance for the big triangle. So 350 is going to go on the bottom here. Then we're going to cross multiply to solve for D, so we're going to get 280D equals 20 times 350. So then that's going to be 280D equals 7,000. Divide by 280. Divide by 280. D equals 25. So it says find the distance of the pond below. So we'll say the distance across the pond is 25, and then don't forget your units, meters. And that's it. Oh, put a box around it. Have a good day.